Nuclear magnetic resonance. This is the 300 MHz magnet. This magnet is ultra-shielded, which means the stray fields created by this magnet stays within the container holding the magnet. When approaching a magnet, you must be very careful not to have any metal on your body or in your body. The sample goes into the top of the magnet and is gently placed into the probe. The probe is installed at the bottom of the magnet and acts as the detector. Your sample will drop down into the probe here. There are tuning rods on the probe so that you can tune the probe for the nucleus you want to detect for: proton, carbon, and nitrogen. Actually, the 300 MHz probe can run proton and X, where X can be anything between phosphorus and silver. The sample being run today is ethylbenzene in deuterated chloroform. First clean the NMR tube, then place the tube in the spinner. The depth of the tube in the spinner is measured using the depth gauge. On the keyboard, press the lift button and a flow of air can be heard at the top of the magnet. Place your sample at the top and return to the keyboard. Turn the air off and the sample will go down into the probe. Shown on the computer screen is a flowchart that will guide you through the process of scanning your sample. It is called C-span. First, you will click on Lock Window. You will see the locking horns of CDCl3. On C-pan, click Lock. Another table comes up with a list of all the popular solvents used. Click on CDCl3. Remember, your solvent must be deuterated. Once the sample is locked, you must adjust the shims to make sure your sample is homogenic with the magnet. The shims used here are Z and Z2. After shimming, go back to C-pan and create a file name for your data. Usually start with experiment number 1. The process number is number 1. The disk unit is where the data is stored. The user in this case is who you're working for, and the type of data is NMR. Back to C-pan, you want to choose the type of experiment you want to run, and for this video we are concentrating on proton and carbon. Go back to C-pan and click on Acquire. Once the proton FID has finished, click on the command Fourier transform. The result is a spectrum. Then click on Phase, Integrate, View your spectrum, then Plot. The next experiment is a cozy experiment. This is a proton-proton correlation. Basically, what is coupled to what? Another standard experiment is carbon. This experiment will tell you where the carbons resonate in the ppm scale. You can see the FID of the C13 is not as pretty as the proton, and that is because C13 is not as abundant as protons. In this C13, you see only the carbons. The protons are taken away. The next carbon experiment that is very useful is a type of DEPT experiment that will differentiate between CH, CH2, CH3, and carbon. This experiment is called Attached Proton Test. Here is the experiment, and you can see that the CH and CH3 are phased down, and CH2 and carbon are phased upright. When the experiments are over, you can remove your sample by pressing Lift on the keyboard, and the sample comes to the top of the magnet. You can now take your sample and spectra back to your lab.